Welcome back to the deep dive. Today, we're cutting right through the noise of some pretty complex commercial AV systems. We're going to look at one essential component, the modular input card, specifically one from a manufacturer with a long history in high-performance matrix switching.
Exactly. And our mission today is really about understanding efficiency. It's about distilling what makes a component like this audio input card so critical.
Yeah.
For those environments that just absolutely cannot afford downtime.
Like a massive sports arena, maybe? Or a data center?
A sports arena, a data center, even a really high-end home theater. This is a deep dive into how you build robustness through design.
Okay, let's unpack this then. I think we should start with the fundamental design philosophy, which seems to be all about modularity.
That foundation is it's absolutely crucial. These modular matrix switchers, they come in these large chassis sizes, 9 by 9, 18 by 18, some are even 36 by 36. But they all rely on an individual one-port slide-in card cage system.
So every single input and output is its own physical part.
It's completely isolated on its own component.
Okay, and here's where it gets really interesting, I think, especially for anyone managing a facility. That isolation has a huge practical benefit. If an input signal is lost, you're not shipping back some massive, expensive chassis.
No, not at all. You just replace that one single card, which might cost, what, a couple $100s? You avoid sending back a piece of hardware that could be tens of thousands. It drastically improves reliability and just saves so much time and money.
So the design handles physical failure, but what about performance? How fast is this signal actually managed? I know the key feature they always talk about is this instantaneous, seamless switching speed. 100 milliseconds.
And that speed is critical.
Yeah.
I mean, think about watching a game at a sports bar. That delay of several seconds you get on a non-seamless switcher. That's the difference between seeing the goal and just seeing a black screen.
So how does it avoid that delay? What's the tech doing behind the scenes?
Well, it's because the high-performance engine is executing all the necessary system negotiations at the same time.
Can you break down what those negotiations are?
Sure, we're talking about instantly confirming the display's capabilities, that's called ED, and then verifying the copyright protection, or HDCP. It does this at the source, and the display ends simultaneously. And critically, it uses an internal memory cache, a frame buffer, to hold the previous input's info.
So it never lets go of the old signal until the new one is totally locked in.
Exactly. That's what eliminates the screen blackout you see in older systems. And what's also fascinating is the universal card design. It's built on DVI technology, and, well, with different adapters, it can accept 4 different input types: HDMI, VGA, component, and even composite.
Wait, hold on. Composite? In a world of 4K and 8K, we're talking about that old yellow plug for resolutions up to 480i? Who actually needs that kind of backwards compatibility anymore?
That's the key insight right there. This card isn't built for raw 4K speed. It's designed for maximum system flexibility. It ensures that an integrator doesn't have to rip out, say, a legacy surveillance system or an older display just to match the new matrix switcher. It's about supporting everything.
I see. And on the audio side, it handles standard 3.5 millimeter stereo audio and lets you separate things. You can embed a totally different audio source on the input card, right? Pair video with a, I don't know, separate commentary track.
You absolutely can. And then you can de-embed it again on the output card. That kind of separation is it's massive for custom jobs. And to manage all those different inputs and resolutions, each card has its own hardware control. It's a tiny bank of manual switches and 8-pin DIP switch. It lets an installer physically set resolution limits, scale the video up or down, to match everything perfectly.
And controlling the whole matrix seems just as flexible. I mean, there are dozens of ways, from a web GUI and mobile apps to big automation platforms like Control4 and Crestron.
Right. And for custom coders, they even provide the RS-232 script. So you have the exact protocol for writing your own simple commands. To guarantee this level of reliability, we have to look at the quality assurance. They use this really critical multi-step testing procedure that includes a mandatory 24-hour aging process in a standardized thermal testing room.
So they're stress testing it before it even leaves the factory.
Continuously. It stresses the components under stable but demanding conditions. It's designed to catch what the industry calls infant mortality failures. Those components that would have failed within the first week of use.
Okay, let's zoom out a bit. So this component system is clearly built for maximum flexibility, handling a huge array of signals, all while making sure downtime is absolutely minimal because of its modular design.
And if we connect that to the bigger picture, it really shows that true efficiency in these Pro AV systems, it's not just about raw switching speed. It's about the operational efficiency that comes from managing complex signals and, recovering quickly from failure by just swapping out a small part.
So a final provocative thought for you. Given the high reliability baked into these systems, how does knowing about that multi-step quality control like the 24-hour aging process change your perception of what plug-and-play hardware actually means?